Hey guys, in this video the brilliant Mr. B is going to be working with Pythagoras Theorem to help you work with triangles. Now this is aimed at GCSE further maths, or if you want an introduction over the summer to A-level maths to help you get started. Now there are 9 different examples here, work through at a nice slow pace, and if you look at the pinned comment down below you can jump between the levels because they get harder as you go along. If you want more practice questions to see if you really understand this, then there are loads more waiting for you over on my website.
We are going to revise Pythagoras Theorem, and then we're going to gradually increase difficulty until we have a look at Pythagoras Theorem questions in 3 dimensions. So to start off, Pythagoras Theorem is when you say that a squared plus b squared is equal to c squared. So what does this mean? Well, I've got a triangle here, and we can see that C is already labelled, and C corresponds to the hypotenuse, which is the longest side. The other 2 sides, doesn't matter which way around they are, we've got side A and we've got side B. So what does the squaring mean? Well, let's imagine that we've got a square that has the same dimensions as side A. So side A, we can see it's 3 centimetres. So let's imagine we've got a 3 centimetre square. So I'm just sketching it, but hopefully you get the idea. Now, on the other side, let's imagine we've got a square with the same dimensions as side B. And side B is 4 centimetres. So every side of this square should be 4 centimetres. And again, I'm just doing a rough sketch here, roughly the right size, just so you get the idea. So we've got an A square and we've got a B square. Now we also need a C square for the formula. So with side C, again, we're going to imagine that we have a square that's got the same length on each side as side C. Now we don't know what length this is yet, but I can't sketch out the square for it. So it's roughly going to be around about this size. Okay, so what does Pythagoras theorem mean? Well, it means that the blue square and the green square, if you add them together, they are the same size as the purple square that I've just drawn. So if I just color code this, the A square plus the B square is the same size as the C square. And we can use this to find missing sides. And we're going to use substitution. So the A square, the dimension of that was 3 centimetres. So that's going to be 3 squared. And the B square, the dimensions of that were 4 centimetres. So that would be 4 squared. And the C square, we don't know the size of that yet. Now, this is related to the area of squares. So if you multiply the base times the height of a square, you get the area. So with a square, all the sides are the same, so the base is 3, the height will be 3. So the total area of the green square is 9 centimetres. The total area of the blue square, base 4, height 4, 4 times 4 is 16. So we know that if the green square is 9 centimetres squared and the blue square is 16 centimetres squared, then the purple square must be 25 centimetres squared. The A square plus the B square is the same size as the C square. Now, what we're looking for here, we don't want to know what the size of the C square is, which we've worked out is 25. What we actually want to know is the length of the side of the triangle C. And you just use your solving equation skills. So I want C on its own. It's not on its own, it's got a squared with it. I need to square root both sides to solve the equation. So C squared and square rooted. Square and square root cancel out, they are inverse operations. And the square root of 25 is 5. So the length C is 5 centimetres. And so this is the essence of what Pythagoras theorem means. We know that the A square and the B square is the same size as the C square. So we can square root that answer to find just the length, the missing length of the triangle C. Moving on to question 2, we're going to be using Pythagoras theorem again. A squared plus b squared is equal to c squared. And we need to label our triangle. So the C is already labelled, it's the missing side, the longest side, the hypotenuse. So the C is always the longest side, but the A and B, it doesn't matter which way around those two are. And all we need to do is substitute into our formula. So if side A is 24, then we want to find out 24 squared. If side B is 32, then we want to find out 32 squared. And if you add those 2 answers together, you're going to get C squared. So to square something, multiply it by itself. 24 squared is 576. And we're going to add on the 32 squared, and 32 squared, 32 times 32 is 1024. So if we add both of those together, we are going to get c squared, which is 1600. So we know that c squared is 1600. Now we need to rearrange the equation or solve the equation to get c on its own. And with solving equations, we've got a squared with it. We have to do the inverse of squared, which is square root. So square root both sides. So c squared square rooted, they cancel out. That's why we chose it. And then the square root of 1600, and you can use a calculator for this, that should give you 40. And just quickly check the units. It's in centimeters, that'll be 40 centimeters. The last step is just check that that measurement is credible. So in our question, we've got a 24 and a 32. And we're saying the answer is 40. Now it's for C, the hypotenuse, the longest side. So firstly, is 40 the longest side? Well, yes, it would be. And secondly, is it kind of close to the others in length? And it's a little bit bigger than the 32. And looking at the diagram, that makes sense. Now, if you had something, like 0.1, so it was too small, or you had a really big number, like maybe you forgot to square root it at the end, and you think, okay, the answer is 1600, that's going to be way too big. Because look at the diagram, it should be a little bit bigger than 32. And 1600 is way too big. So just use a bit of logic at the end, just to make sure your answer kind of fits in with the measurements on the diagram. So for our next example, we have another triangle. A really important thing is that the triangle has a right angle. If it doesn't have a right angle, you can't use Pythagoras Theorem, which is a squared plus b squared equals c squared. If you had this question and it didn't have a right angle, we don't need to use something called cosine rule, which is a modified version of this with a bit of trigonometry on the end to adjust for it not being a right angle. So that'll be one of the next videos. So you write down Pythagoras Theorem, where you're going to label the triangle. So label the sides, A and B, doesn't matter which way around, as long as C has got to be the longest side. So substituting, so A squared is going to be 12 squared, which is 144. B squared is going to be 5 squared, which is 25. And if you add those answers together, we get what C squared is. So 144 plus 25 gives us 169. So C squared is 169. Now we need to know what C is. And with a lot of these questions, there might be non-calculator questions, and you might need to recognize that 169 is a squared number. You need to memorize which square number it is. And the one is, it's 13 squared is 169, with the answer being in centimeters. So if you've got a calculator, perhaps with the larger numbers, like the last example, yeah, you can use a calculator, but for some of them, you'll have to recognize yourself that 169 is a square number, and knowing the square root is 13, because 13 times 13 is 169. Moving on to the medium questions now, they're going to stay the same in terms of the method to start with. So always write any formula, it'll help you to remember it. A squared plus b squared is equal to c squared. Check you can use it, you've got to have that right angle there. And then label. Now, for this one, A has already been labelled, and A is this side here. We know that A is one of the short sides with no value for it. B must be the other short side. That means that C must be the 60 centimeters. Now, if you're not sure how we know 60 centimeters is genuinely the hypotenuse, it's genuinely the longest side. So there's two ways. The first way is to just do it by inspection. Look at that line, and you should be able to tell that this line is longer than this line. So the pink line is longer than the line I'm highlighting in green. If you genuinely can't tell that the pink line is longer, another method is that the pink line, you'll notice, does not touch the right angle. It is opposite the right angle. So another way to check, just look, right, which line doesn't touch the right angle? That must be the longest side. So let's substitute like we normally have. Now, we don't know what A is, so we'll have to leave A alone. But we can work out B squared. That's going to be 48 squared. And 48 squared is going to give us 2,304. And then unusually, know what the answer is. C squared is going to be 60 squared. And we can work that out. 60 squared is 3,600. And so this is what we're left with. A squared plus 2,304 is equal to 3,600. So what we need to do now is we need to rearrange this equation to make A be the subject of it. So we can take away 2,304 from both sides. That will leave us with a squared, but did nothing with that. 2,304 take away 2,304 is 0. That's why we chose it. And then we have 3,600 take away 2,304. And that gives us 1,296. So we've worked out what a squared is. Now we just want a on its own. So again, if you're rearranging equations and solving equations, it's a squared. We've got to get rid of the squared. Square root is the opposite of squared. So we square root both sides. That means you're square rooting the 1,296. And the answer is 36. It'll be 36 centimeters. Now, again, once you get your answer, just check the numbers. Is this the longest side? Well, the longest side is 60. This is 36. It's not the longest side, and A shouldn't be. C should be the longest side. And it kind of fits in with 48 and 60, so it looks like we've got the correct answer here. So the difference with median questions is sometimes you're given what C squared is, and you have to kind of work backwards in a way to figure out what A or B is. And to do that, you do a little bit of rearranging of the formula at the end. So moving on to the next example. Again, write down Pythagoras Theorem. Always double check you can use it, and we do have a right angle there, so we can use it. Label the sides. So A is already labelled, and I want to label side B and side C. And if you're not sure if C is actually the longest or not, it's opposite the right angle. No part of line C touches that right angle. So C's always, always, always got to be the hypotenuse, the longest side. So substitute in. So a squared, we don't have a value for. We'll have to leave it as it is. But the b squared, we can work that out. It's going to be 68 squared. And it's going to equal c squared, which is 85 squared. So we can work out those values. So 68 squared is 4,624. 85 squared is going to give us 7,225. And we need to make a squared be the subject, a squared equals. So we need to rearrange the equation. So what's with the a squared? Let's got 4,624 with it. Let's start out by taking that away from both sides. We do 7,225, take away 4,624. Our answer is 2,601. Now, that doesn't fit in with our numbers. We've got a 68 and 85. 85 should be the longest, and our answer is 2,601. That's way too big. So that should be telling you that we've forgotten to do something. And we want to get a equals as our answer, not a squared equals. So what we need to do is we need to square root both sides. So the 2,601 square rooted should give you 51. So the answer is 51 centimeters. And that number does fit in with the two values we have. It's quite close to 68. Moving on to our last example of this type. Again, we have a right angle triangle. So we can use Pythagoras theorem. A squared plus b squared equals c squared. Now we label the sides. We can see that b is already on there, and it's a missing side. Side C of the longest, which is the 29, and the other one we can label with the A. Now, what we really want here is we want to rearrange this where b squared is equal to something. Now, the last two questions, we rearrange our equation at the end when we had values substituted in. I'm going to show you here how you can rearrange at the start. So we want it to be b equals, because we're trying to find what b is. So what we need to do is get rid of the letter that's with the b, and it's the a squared. So we're going to take a squared away from both sides, and that gives us b squared is equal to c squared take away a squared. So we've done our rearranging at the start, and now we can substitute in. So we don't know what b squared is yet, but we know that c squared is going to be 29 squared, and then a squared is going to be 20 squared. But if you rearrange it, what we get is we get a takeaway. So b squared is going to be equal to 29 squared, which is 841, take away 20 squared, which is 400. So b squared is 841 take away 400, which is 441. To finish off, we want to know what b is, not b squared, so we need to square root both sides. The square root of 441 is 21. So our answer is going to be 21 centimeters. Again, at the end, let's check that it fits in their numbers. Well, it's right next to the 20 centimeters, which is the other short side, and it's smaller than the longest side, 29 centimeters. So it seems like this answer fits in. Another big thing with this is that there's only a limited number of values in Pythagoras theorem. that are going to give you whole number answers. So if you do get a whole number answer after squaring or square rooting something, that's a pretty good guarantee you've got the right answer. Do watch out though, because you can have questions with decimal answers as well. So if you get a decimal, it's not wrong, but if you get a whole number, it's an extra sign that you've probably done something right. Now, if the hard questions, we'll use Pythagoras Theorem with 3D shapes. So here we have a cube, and you will be told in the question this is a cube, either by the word cube being used or with dashes on the sides, which indicate that all the sides are equal in length. And for this question, what we want to find is the length of the red dotted line. Now I'm just going to highlight this in pink. And this line, it goes from the back top corner to the front bottom corner. So how can we find the length of that line? Well, the way to do this is to draw extra lines in your diagram. So let's imagine we are also using the kind of back line there, and we're going to join it up into a triangle like this. So we've got a triangle inside, and this is going to be a right angle. It doesn't look like a right angle just because it's diagonal to our point of view, but it will be a right angle. And what I'm going to do is I'm going to sketch that triangle. So we're looking for the hypotenuse. We'll label with an X. We know what the height of this is. This is going to have a height of 8 meters. And we know that because in a cube, every single side is going to have the same length. But we don't know the length of the base. And we don't know the length of the base because it's not one of the sides. It's kind of a diagonal within the cube. So how do we find what the base is? Well, I'm just going to highlight first our pink triangle. To find that length, I'm going to make another triangle. I'm going to highlight this one in green. So we're going to use the same edge that we're trying to find. We're going to use two edges that we do know. We know that this is 8 centimeters, and we know that this is 8 meters. And so I'm going to sketch out this triangle as well, which is flat on the base of the cube with a right angle in the corner. Now, in this triangle, we know two lengths. We have the base that's labeled 8 meters, and we know the height's going to be 8 meters because, again, in a cube, every single length is the same size on the outside. What's not the same size are these diagonal lengths we're trying to find. So to find the diagonal length, the hypotenuse, in a green triangle, we're going to have to use Pythagoras Theorem. So we're going to use a squared plus b squared is equal to c squared. So we know that a squared is going to be one of the 8s. The b squared will be one of the 8s, two short sides. And so c squared is going to be the answer to that. 8 squared is 64. So 64 plus 64 is equal to c squared, which is going to give us 128. So c squared is 128. We don't want to find c squared, we want to find c. So c is going to be the square root of 128. Now, if you pop that into your calculator, you're going to get 11.3137085. A lot of decimal places. So to make this easier, I'm going to leave it as a square root for now. I'm going to leave it as a third. Moving on to my pink triangle, we know the base of this pink triangle is a square root of 128 meters. And I'm just going to highlight this. You can see the blue edge I'm highlighting. You can see that's part of both triangles. And that's what we've just found, the 128. So now we're going to use exactly the same working out. So a squared plus b squared is equal to c squared. So a and b are the two short sides. Doesn't matter which way around they are. So maybe we can say a is going to be the 8 squared. B is going to be the square root of 128 squared, which is all equal to c squared. Now, I'm writing c squared here, but you know I've labelled it with an x, haven't I, on my diagram? So why don't we just call it x squared? Just so we're telling the difference between the c squared with the green triangle and the x squared in the pink triangle. And the a, b, and c in Pythagoras Theorem, the arbitrary letters that we've chosen, you can use any letters you like, really. So 8 squared is 64. But what's the square root of 128 squared? Now, it seems like it's really hard, but think about it. A square root and a square cancel out. So it's just going to be 128. So it actually made it a little bit easier for us by not actually rooting that number because it's going to be undone later anyway. So 128 plus the 64 will give us 192. So our x squared is equal to 192. So we just want the side x, so we need to square root the 192. Now, what we do next depends on what the question asks you to do. If it wants an exact answer, then we leave the answer like that. Now, why is that? Because if you do the square root of 192 on your calculator, you're going to get 13.8 85640646. And that's probably going to be an irrational number. There'll be more decimal places after that. It all depends on how many decimal places your calculator can handle. So your calculator's rounded it off to, for me, it's 8 decimal places because that's all it can fit on. That answer is not exact because we've cut something off. So we leave it as a square root. We want an exact answer, full accuracy. Now let's say we wanted 1 decimal place, then we could say it's 13.9 meters. So we've asked for the value, and in this case, we've got it to 1 decimal place. Then you can actually do the square root. So look really carefully at what the question's asking. If it doesn't specify an exact value or a rounded value, then just round it something reasonable like 1 or 2 decimal places. So moving on to the next question, let's try and bring all this together into a quick method we can use. So firstly, look at the line it's asking you to find. In this case, it's the line that goes from top back corner to the front right corner. And I'm just going to trace this in green. And what we're going to do is we want to form a triangle that includes that line so we can use Pythagoras theorem. So I can use the height of the shape, then we're going to cut across the base. It's going to have a right angle in it, otherwise we can't use Pythagoras theorem. Once you've identified the triangle, sketch it and label all the sides you can do. Now, the green line that cuts across the base, we don't have a measurement for that yet, but we do know the height is going to be 7 meters. And I'm going to label the side I'm going to try and find as X. So I need to complete this, I need to know the measurement of the base. So what I'm going to do is highlight the measurement of the base in another colour. And I'm also going to form a triangle out of that. And again, it needs to have a right angle so we can use Pythagoras theorem. And this triangle should have 2 measurements. We can find a completeness. So let's sketch a triangle. Because the 3D diagram is quite confusing to work with, especially the perspective, making it not look like right angles. So I'm going to label the side I'm trying to find here C. Again, any letters, doesn't matter which letter you use. We know the base is 5 meters, and we know the height of this triangle, it's parallel to the 4 meters. So don't pretend to write 7 there, because it's not the height. This one's flat on the base of the shape. So it's not the height of the shape, it's the depth of the shape. So now we can use Pythagoras theorem to work out what C is. It's a squared. We've not labelled the sides. It doesn't matter which way around the A and B are, as long as it's 2 short sides. So we can have 4 squared plus 5 squared is C squared. That would be 16 plus 25, which is going to give us 41. So C squared is 41. Therefore, C must be the square root of 41. And the square root of 41 is going to give us 6.403124,237. Those digits will continue depending on how big your calculator screen is. So we're going to leave it as an exact value. We'll leave it at the square root of 41. And we know now, again, just highlighting this, what we've just found, I've highlighted in blue, and it's the base of that green triangle. That's why we did this. It's the base of the green triangle is the square root of 41 meters. So now we can do Pythagoras theorem on the green triangle. A squared plus B squared is equal to C squared. A and B will be the 2 short sides, the 7 squared and the root 41 squared. And then the C squared will be the longest side. So I labeled that with an X. Let's call it X squared. Let's work it out. So 7 squared is 49. The square root of 41 squared, again, a square root and a square cancel out. So that'll just be 41. So 49 plus 41 is going to give us 90. So we've worked out that X squared is equal to 90. That means that X is equal to the square root of 90. And if you're asked for an exact value, then that is your final answer. If you're not asked for an exact value, and you just asked for the value, maybe you're given some roundings, let's say 1 decimal place, then we need to do the square root of 90 on our calculator. And square root of 90 to 1 decimal place should be 9.5 meters. So again, just read through the question carefully and try and figure out what you've been asked for, an exact answer or a value, maybe with a rounding given. And the rounding's not given, just do 1 or 2 decimal places. Now, for the final 3D Pythagoras question, for this one, we are going to find the height of the pyramid. Now, you might be confused because you might think there's already a height. It's because we've got this 17.6 figure, but this is the slant. And the slant is kind of like the slanted height of the slanted triangular face that you can see on the front of the pyramid. The height is called the perpendicular height, and this height is going to go from the top and it's going to go down to the center of the base, and it's going to be at a right angle to the base. So how do we find the height? Well, again, it's all going to be about finding triangles, so we can use Pythagoras theorem. So for our first triangle, the slant and the perpendicular height down to the center of the base will make a triangle if you cut across the middle of the base like this. So let's sketch that. And once you've sketched it, and it's got to have a right angle in it, otherwise Pythagoras theorem won't work. Write in the measurements you want. So we want the height. We don't know how high that is yet. We have the slant, 17.6 meters. We don't have the base of this. We don't know the measurement across the center of the base that we labeled there. So we can't work out this triangle yet. So we need to make another triangle. Now this triangle, we want to find the base, so we'll include that. So why don't we include the 13 meters on the outside as well? So we've got this pink triangle that's flat on the base of the pyramid. So let's sketch that. And again, sketching the separate triangles is really useful because you put all this working out on the actual 3D shape. It will start to get a little bit confusing. There won't be enough space for all the labels. Now, which measurements do we know for this triangle? Well, we know the hypotenuse is 13 meters. But it looks like we're in trouble because the one we're trying to find, which I'm going to label X here, we still don't know that, but we don't know the other side either. Or do we? Now, the whole thing with this is that with a pyramid, this is a square-based pyramid. So if from a corner to the center is a length X, then on the other side, that's from a different corner to the center. So that's also going to be X. So the two short sides are going to be the same length. Now, they're not the same length in terms of how I've sketched it, because the perspective doesn't look like that. But logically, they should be the same length. Well, can we solve Pythagoras theorem with two missing sides? Well, we can, only if there's a relationship between the two missing sides. And in this case, they are both the same size. So we have a squared plus b squared is equal to c squared. A squared, well, the two short sides both labelled x, so it'll be x squared plus x squared is equal to c squared. So that'll be 2x squared, two lots of the x squared is equal to c squared. But we can work out c squared because it's 13, isn't it? The hypotenuse on this triangle is 13. So c squared means it's going to be 13 squared, which is 169. All we need to do now is rearrange the equation. So let's divide both sides by 2 first. Usually better to work in reverse big mass order with these. So 2x squared divided by 2 will be 1x squared, and 169 divided by 2 will give us 84.5. Then we need to square root. So the square root of 84.5 is going to give us, so we're square rooting both sides, x is going to equal, and it's 9.192388155. So why don't we leave it as a square root? Let's leave it as an exact answer. And now we know the base of the green triangle. It's the square root of 84.5 meters. So now we can work out Pythagoras theorem. So we have a squared plus b squared is equal to c squared. Now we're looking for one of the short sides here, aren't we? So why don't we do the rearranged version of this? So let's call it, if you think about why this worked in the previous questions, a squared is equal to c squared take away b squared. So just rearrange Pythagoras theorem. And we'll call the h the height a. So that will be h squared. The height squared. So c squared is the hypotenuse, the longest side, which we're told in the question was 17.6. So that'll be squared. We're taking away the square root of 84.5 squared. That we'll call that side B, the other short side. So to work this out, h squared is going to equal, so 17.6 squared is 309.76. The square root of 84.5 squared, square root and square will cancel out, leaving us with 84.5. So we just need to take those two away from each other. And that's leaving with h squared is equal to 225.26. And I want h on its own, so I need to square root it. And so the square root of that number is 15.0 to 1 decimal place. Now you might be tempted just to write 15 here, but you can't because this number's not exactly 15. I'm getting 15.008666416. So it's not quite 15. So when you do round it, you can't write 15. You have to write 15.0 because you're just explaining that this number isn't exactly 15, but to 1 decimal place it is. But it's letting someone know that if this was maybe 2 decimal places, it wouldn't be 15, it'll be something else. And in this case, at 2 decimal places, it'll be 15.01. Just let you know how accurate this answer is. So again, if you ask for an exact answer, then the version with the square root symbol will do. And if you ask for a value, then really, look for what the rounding is going to be. If it doesn't say anything, then 1 decimal place should be fine.
Ouch. Love you too, Crim.